So basically, we are going to solve one more problem based on Routh's array, Routh's criteria. Okay. So basically, this criteria is used to find the stability of the given system, which will be given in characteristic equation form. So here we have taken one characteristic equation. We are going to find out the stability of this system, whether it is stable or unstable. Okay. So let me just. So first step is basically you have to see whether all the powers are present or not. The power is starting from s power 6 in decreasing order 5, 4, 3, 2, 1 and 0. Here you can write s power 0 if you want s power 1. If it is any power is missing, you have to just put it as 0 s power whatever the power is missing. Okay, that is the thing. Because when you write, you have to understand that one missing thing, you have to write it as 0. Otherwise, it is wrong. So here on the left hand side of Routh's array, you have to write the powers in decreasing format, starting from the highest power, that is s power 6, then s power 5, then s power 4, 3, 2, 1 and 0. So here s power 6 and s power 5. Always remember the first two rows you can directly write it from the characteristic equation which is given in the question. This equation, from here we can write first two rows. How to write these elements? So basically we are having two methods. First method is that you can write by starting with the odd position powers. Okay, odd position means first position, third, fifth, seventh, like that, leaving 1 1. Okay, I'm not telling odd power, I am telling odd position of the elements or the terms. So starting with this coefficients you have to write. Okay, so I'll write 1, 8, 20 and 16. This you have to write in the first row. Okay, now the left out one, even position, this one, this one, this one. Okay, two coefficients you have to write 12, 16, and here we don't have any term, so it will be 0. If you don't have that term, write it as 0. So I'm going to tell you how to write directly by looking at this. Always remember the condition is that you have to take the descending order format, that is nothing but starting with s power 6 till s power 0 descending order, and no power should be missing, all should be in order wise. Okay, s power 6, s power 4, s power 5, 4, 3, 2, 1, 0. Okay, all the power should be there. If it is anyone is missing, write 0 s power whatever the missing thing. Okay, now write order wise only. How to write? First two rows we can write by looking at this characteristic equation that we know. So just we have to fill first two rows. Starting with here 1 is there, then 2. So 1 I'll write here, 2 I'll write down. Column wise I'll write. Okay, you have to write column wise here. So 1, 2, then 8, 12, 8, 12, then 20, 16, 20, 16, then 16. What about this one? It will be 0 because no other element is there. So basically in order wise you can write it as what? Column. Just write it column wise, 1, 2, 8, 12, 12, 16, like that. Okay, now next thing, this element you have to write. How to write this element? So you have to understand, you have to multiply 2 into 8 minus 12 into 1 divided by this element, that is 2 into 8. Always 2 into 8 you have to do. That means you have to start from the bottom left to the top right, always, minus 12 into 1 divided by that particular element, that is 2. Okay, so what is the answer of this? 16 minus 12 by 2, which is equal to 4 by 2, that is equal to, I can write it right here as 2. This element, always remember you have to observe only this 2. You have to take this as reference. Now multiplying 2 with 20 minus 16 into 1 divided by this element only, that is 2 into 20 minus 16 into 1 divided by that element only, that is 2, which is equal to 40 minus 16, divided by 2, which is equal to 24 by 2, it is 12. So here it will be, now this element, that is again 2 into 16 minus 0 into 1. 2 into 16 minus 0 into 1 divided by 2. You can observe the denominator is fixed. You have to consider only this element, this 2. Okay? That is 32 by 2, which is equal to 16. Now what about this element? Since there is no elements over here, you cannot multiply only. That means it is 0. So this element will be 0. Okay? So s power 3, this element, how to write? Now we have to see this 2. Okay, starting we saw these two elements, now we have to see these two elements, and denominator will be this one. So top to sorry, bottom to top right, it is 2 into 12 minus 2 into 12. 2 into 12 minus 2 into 12 divided by the element is 2. So it will be 0 by 2, which is equal to 0. This has become 0. Now next 2 into 16 minus 2 into 16. 2 into 16, 2 into 16 divided by 2 equal to again 0 by 2, 0. This element 2 into 0 minus 0, again 0, this also will be 0. That means here you can observe that we have got one condition here. So all the elements of particular row, this S3 row has become 0. Right? All the elements in this row. So this row we call it as row of zeros. So whenever a particular row becomes, or the elements of the particular row has become 0, all the elements, that row we call it as row of 0. Now what you have to do, we have to delete this row of 0. How to do that? You have to form the auxiliary equation A of s. That is nothing but how to form that equation. Above this row of 0, just above that row of 0, we have one more row, correct? Not below, above, just above, that is s power 4 row. From that you have to write the auxiliary equation. Now how to write? Let us see. So basically you have to observe this particular row, correct? The first coefficient we have 2. This is s power 4 row, correct? S power 4. So you have to start with s power 4 only. The coefficient here it is 2 and s power 4. 2 is there and the row is s power 4. Plus next element we have 12. The coefficient is 12. Then we have to write s power 2. What am I doing? I am just subtracting the power with 2. That means power you have to subtract with 2. Minus 2 you have to do. Okay. Plus 16. 16 s power 2 minus 2 is 0. So s power 0. Plus we have 0 here. No need to write also. So this is the equation we are getting. Equal to 0 you have to put. Now we have to differentiate this auxiliary equation. Okay, if you want you can simplify this equation by taking 2 also. It's the same thing. Okay, but the thing is that differentiated equation will be different, but the final thing, final whatever array you're getting, that will be same. I'll tell you how to see that final thing. So let me just differentiate. So 2 4 into 2 8, 8 s power 3 plus 2 into 12, it is 24. Subtract 1 here, so s power 1. Anyways, this is nothing but constant itself. Okay, so that will be 0. No need to write that. So differentiated, we have got equation. Now I can remove this row of zeros. I'm going to remove the row of zeros. Now here we have got 8 and 24 as the coefficient. Here you can see it is s power 3. Here also you can see it is s power 3. So this element will be 8. This element will be 24. Here also you can observe s power 3 has become not become, it has next term is s power 1 minus 2. As I said before, it is minus 2. Powers are decreasing by minus 2. And what about this and this element? It will be 0 because we don't have that terms. So the row of 0 has become what now? Some elements has come. It has been deleted. Now let us go for s power 2 row. Again the same thing. 8 into 12 minus 24 into 2 divided by this element, that is 8. 8 into 12 minus 24 into 2 divided by 2, sorry 8, that is equal to 96 minus 48 divided by 8, that is equal to 48 by 8, which is equal to 6. This comes. Now next one, 8 into 16 minus 0 into 2. 8 into 16 minus 0 into 2 divided by 8. 128 divided by 8 is equal to 128 divided by 8 becomes 16. Okay, so this element becomes 16. These two elements will be 0. If you multiply and see also, 8 into 0 minus 0 into 8, it will be 0 only. Now let us go for s power 1. For s power 1, now this will be the our element. 6 into 24 minus 16 into 8. 6 into 24 minus 16 into 8 divided by, what is that, 6. So 24 into 6, which is equal to 144, minus 16 into 8, which is equal to 120, divided by, so what will be the answer? 16 divided by 6, which is equal to approximately 2.67. Okay, I can write it as 2.6, or you can write 16 by 6. Next, 6 into 0 minus 0 into 8, that is nothing but 0 itself. There is 0, this also will be 0. This, no, s power 0. So 2.6 into, let me just clear this one. So this one, 2.6 into 16 minus 0 into 6. 2.67 into 16 minus 0 into 7, 0 into 6 divided by 2.67. So what will be the answer? It will be 42.72 divided by 2.67, which is equal to 16. Okay, this element we are getting it as 6. What about this elements? It will be 0. You can multiply and see 0 only. So basically you need to understand here, as I said before, the last element, this element should be same as the question you can see here. This is s power 0. This is also s power 0 row. This coefficient is 16. Here also it is 16. So s power 0 coefficient should come here. Correct? That way you can understand that you have done correctly the methods, the Routh's array formation. Okay. Now here we observe that there is no sign change. That means from the first column, you have to always see the first column of the Routh's array. We can see there is no sign change. Correct? Because all the signs of the given elements, that means whatever we have found out, it is positive. Positive 1, positive plus 2, plus 8. There is no sign change. Correct? All the elements we are getting as positive. So that means there is no sign change. The system may be stable. We are not sure. But the problem here is that we had got one row of zeros. Correct? Row of zeros we got. That's why system will be, there are two possibilities. Since there was a row of zeros, the system may be marginally stable or unstable. In order to identify whether it is marginally stable or unstable, we have to find out the roots of oscillatory equation. So let us go for finding out that. So oscillatory equation, we know that it was 2s power 4 plus 12s power 2 plus 16 equal to 0. Now from here we can just simplify this one. This is taking 2 as common, so it is nothing but 6s square plus 8 equal to 0. Okay, now from this equation I can just write s square as x also, because this is not quadratic. Quadratic will be simple to solve. Okay, s square I will write it as x, so this becomes x square plus 6x plus 8 equal to 0. Simple. Okay, now x square plus 6x plus 8 equal to 0, I can solve. Basically, x is equal to minus b plus or minus square root of b square minus 4ac by 2a is the quadratic formula through which I can solve. What is b? It is 6. So minus 6 plus or minus square root of 6 square b square minus 4 into a value is 1 into c value is 8, correct, divided by 2 into 1, that becomes minus 6 plus or minus square root of it will be 36 minus 8 fours are 32 divided by the x value becomes minus 6 plus or minus square root of 36 minus 32, it is 4 by 2, so that becomes minus 6 plus or minus 2 by 2, correct. So 2 I can take common, so this becomes minus 3 plus or minus 1, correct. Basically I have taken 2 here common. 2 common means minus 3 plus or minus 1 by 2, right? 2 to cancel, that's why it is minus 3 plus or minus 1. That means I can take minus 3 plus 1 and minus 3 minus 1. Minus 3 plus 1 will be minus 2. Minus 3 minus 1 will be minus 4. So basically I have got two roots. Why am I getting two roots? Because I have considered it as, for this I am finding out x square plus 6x plus 8 equal to 0. For that I will be getting two roots since it is a quadratic equation. So x values I got minus 2 and minus 4. Now what about s values? S square I consider it as x. That means it is equal to minus 2 minus 4. So s square I can write it as minus 2 and one more s square I can write it as minus 4. Correct? So s value becomes minus 2 square root plus or minus, and here also s value becomes plus or minus square root minus 4. So this one I can write it as s equal to plus or minus root 2j, because it is square root of minus, right, minus square root of minus 2. Square root of minus 1 is nothing but j. So I can basically write square root of minus 1 j and root 2. What about this one? This will become plus or minus 2j, correct. Square root of 4 is 2 and minus 1 square root is j. So this is the s values. Now I should basically get what? 4 roots, because in our question you can see we are basically finding out the roots for this one, 2s power 4. So I should get here 4 roots. Okay, so what are the roots here? S values is nothing but plus root 2j minus root 2j, then from here it is plus 2j and minus 2j. These are my basic the roots. Now here we are getting, let me just plot first, then I'll tell you what will be the, whether it is marginally stable or unstable. So this is the imaginary line, this is the real part line. Okay, 2j, 2j I can mark here 2, 2j plus 2j, so minus 2j will be here. Then root 2j, root 2 value is nothing but 1.41 something, right? So root 2j means 1 point somewhere around here I can mark. Okay, this is root 2j, minus root 2j will be somewhere here. So here you can observe that the roots are basically non-repeated. There is no repeated roots. I can say that non-repeated roots. Non-repeated roots, and they are situated on the imaginary axis. Therefore, the system will be marginally stable, not unstable. Okay, we had two options. One is unstable and marginally stable. Always remember, when it becomes unstable, when there is a repeated imaginary roots. That means repeated roots which are situated on the imaginary this thing. axis. Marginally stable means non-repeated roots and which are situated on the imaginary axis. Okay, that is the thing. This when we have to find out, because we have got one row of 0. That's why when we are getting row of 0, then we have to go for this thing.